In this video we're going to learn a couple of things. The first thing we're going to learn is about variables. Variable. A variable is a letter that takes the place of a number. So it represents a number. Here's an example. 4 plus C equals 6. So this is called an equation right here. And 4 plus C equals 6. Do you know what C equals? What would C be equal to? Well, in order for 4 plus C to equal 6, this number here should be a 2. And then it works. 4 plus 2 equals 6. Here's another equation with a variable. 5 plus 7 equals H. What does H equal? Well, 5 plus 7 equals 12, so H is equal to 12. The variable takes the place of a number, so sometimes we use letters instead of numbers. Here's one more example of a variable. Y minus 4 equals 10. That's an interesting one. Y minus 4 equals 10. So let's say that Y represents yo-yos. Alright, yo-yos. Those are fun. You know those round things with the string? Person holds them in their hand. Yeah. So getting back to this, Y minus 4 equals 10. So some yo-yos take away 4 of them and we end up with 10. So what does Y equal in this case? Well, Y would equal 14. 14 minus 4 equals 10. So I could get rid of the Y and put 14 here. 14 minus 4 equals 10. So in this instance, Y is equal to 14. And Y is our variable. Now I'd like to talk to you about expressions. No, not the kind where somebody has a really scared expression on their face, or somebody is laughing away and can hardly control themselves. Ha 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 ha. That doesn't look like laughing, but you get the idea. Not those kind of expressions, math expressions. An expression uses a variable and a number to represent a pattern. So a variable, remember, is like a letter, so like D, and a number, so maybe plus 2, to represent a pattern. Let's do an example so you get an idea of this. So here we have a pattern of dots. Now if you notice, the first figure right here has how many dots? 2. And the second figure right here has 3. And the third figure has 4 dots. And the fourth figure has 5 dots. Okay. Now to write an expression, we want to find a connection between the figure number and the number of dots. So figure 1 and the number of dots. Figure 2 and the number of dots. We want to see a connection here. How do we get from 1 to 2? We add 1. How do we get from 2 to 3? We add 1. How do we get from 3 to 4? We add 1. How do we get from 4 to 5? We add 1. So there's a pattern happening, isn't there? We're not looking up and down. Instead, we're looking side to side. And we notice that in our pattern, we are adding 1 each time. So the expression is the figure number, we would represent as F, plus 1. That will tell us the number of dots. So if I asked you, well, what about figure 5? How many dots will that have? You could probably tell me that figure 5 will have 6 dots, because the figure number plus the number 1 plus 1 equals the number of dots. Let's do another example. Alright, here we have a pattern of line segments drawn on dot paper. Well, I'm going to make a table, a T-table, and on one side I'm going to have the figure number. So I'll just write fig number, try to do it neat for you, and number of dots. Okay, so in figure 1, how many dots are there? 1, 2. And in figure 2, right here, do you see how many dots there are? There are 3. And in figure 3, there are 4 dots. And in figure 4, there are 5 dots. And in figure 5, there are 6 dots. Alright, I'm just going to extend my table a bit. Okay, so now to write an expression, we want to find a connection between the figure number and the number of dots. So from the figure number and the number of dots, we're looking horizontally across the table. How did we get from 1 to 2? Well, we added 1. How do we get from 2 to 3? We added 1. How do we get from 3 to 4? We add 1. And from 4 to 5, you betcha, we add 1. And from 5 to 6, of course, we add 1. So there you see a pattern. Our figure number plus 1 gives us our number of dots each time. The figure number plus 1 equals the number of dots. So to write an expression, we could write figure number, I'm going to choose f as a variable for figure number, plus 1. This is an expression. It has a variable, f for figure number, and it has kind of an action of plus 1, and that gives us the number of dots. And the reason that's important is, what if I asked you to tell me figure 50? How many dots would figure 50 have, I guess? Well, instead of drawing it or making a really long table, this is easy. If you look at our expression of f plus 1, so figure number plus 1, we would just substitute the f for the 50. So we would have 50 plus 1. What's 50 plus 1? 51. There we go. So figure number 50 would have 51 dots. And that's how we use expressions to help us. Here's one more example of writing an expression. Let's say that we have a pattern like this, 6, 7, 8, 9, 10, and we need to write an expression. Well, we always start by making our table, a T-table. And on one side, I'm going to have the term number, and then on the other side, I'm going to have the actual number that it is. And I just use the number sign. So term 1, in this pattern here, what's term 1? The first term is a 6. What's the second term? It's a 7. The third term is an 8. The fourth term is a 9. And the fifth term is 10. Excellent. All right. So now to write an expression, let's look for a pattern between the term number and the actual number. So from 1 to 6. How do we get from 1 to 6? Well, we add 5. And from 2 to 7, we added 5. And from 3 to 8, we added 5. And now you're probably seeing a pattern that we add 5 each time. So our expression could be T for term number plus 5, because that's what we're doing each time here. We're adding 5. T plus 5 is our expression. And that's great, because if I asked you, well, what would be the number in the 100th term? Wow. Well, instead of making a really long table or, writing this out, that's a lot of numbers to write out. If our term is 100, we can substitute that for t. So we would have term 100 plus 5 equals 105. So term 100 will equal 105. And that is using expressions and tables. So this is an expression right here, a variable and an action. And there you have it. Expressions. Yay!